Hi guys, welcome to question 2 of the 2017 electricity paper. I'm just going to be continuing off from last video. So, question 2, light bulbs. Sam is using a light bulb rated this. Calculate the current flowing through the bulb when it is working at the stated voltage of 9 volts. Alright, so looks like we're given a voltage and a power value. So if we go P equals IV, and we're going to rearrange that to find the current. So I equals P over V. So we're going to get the current is going to equal the power, which is 12 watts, divided by the voltage, which is 9. So the current is, if I put that, divided by 9. Okay, we're going to get 1.33 amps. And that's the final answer, and I've just rounded it to very significant figures. So this is an achieved mark. Okay. Sam then connects two identical 9 volt 12 watt bulbs and a 12 volt battery and a rheostat, which is meant to be shown here, but it's not. Explain how increasing the resistance of the rheostat affects the voltage across each bulb. Okay, so let's just focus on this circuit here. So notice how these two are in parallel, which means they're going to share the same voltage of 9 volts. So, and if we want to, what does it say? Explain how increasing the resistance of the rheostat affects the voltage. So we're going to find out by increasing the resistance by the rheostat what that actually does to the voltage. Does it stay the same? Does it go down or does it go up? Well, since the combined bulbs are in series with the rheostat, it can be said that the total voltage, so we've got 12 here, minus 9 equals the voltage of the rheostat. So that means this must be 3 volts, since 12 minus 9 equals 3. Now, as both the rheostat and the combined bulbs experience the same amount of current, because the current is the same in a series circuit, that means increasing the resistance of the rheostat is going to increase the voltage. So the voltage is going to go up here. Now, the voltage, remember, if the voltage goes up here, that means the voltage by the light bulbs is going to decrease because it has to stay within this 12 limit. So let's say, for example, this became 6 volts. Okay, that means these two bulbs here is going to drop to 6 volts, for example. So I'm going to write that out as a paragraph. As the combined bulbs are in series with the I probably spelled it wrong. Rheostat. V, well, total, which is the 12 volts, equals V bulb, or bulbs, plus V rheostat. Okay? I'll just put that in bracket. As both rheostat and bulbs experience the same current because it's series, increasing the resistance of the rheostat is going to increase the voltage. V equals IR, and current remains the same. Since V of rheostat increases, and the 12 volt battery is fixed, V bulb must decrease because it cannot go over that 12 volt limit. Okay, that's all you need. Let's see, this is a merit level question, so a full answer would get you to a merit. Achieved would be voltage across the bulb decreases, or voltage across the rheostat increases. So, this part. Okay, next question. Show that the resistance of the rheostat must be 1.13 ohms in order for each bulb to be operating at 9 volts. Okay, so we can start off by finding the total current. Okay, I just means current. So we know from our previous part A, we found that the current flowing through one bulb was 1.33 amps. So that means there must be 1.33 times 2, which is 2.67 amps in the whole circuit. So if I write that down, I'm just going to call it bulb total. Actually, that should be current, not voltage. Equals 1.33 times 2, which I'm going to round it to 267 amps. So now we've got the total amp, and because the rheostat is in series with these two, we can just go V equals IR, because we know the voltage of rheostat is just 12 minus 9, because here's my 12 volt supply battery, and these two light bulbs are taking up 9 volts, so that means this has to be 3 volts. So now to show that the resistance is 1.13, we just rearrange it. So I'm going to go over here. I've got V equals IR, so R equals V divided by I. R equals 3 divided by 2.67, so R is just going to equal 1.125 ohms. That's the unrounded answer, so if we round it up, it's going to be 1.13. Alright, so since it is a show question, it's very important you always have the unrounded answer. So you must have, to get merit, for achieved, you either correctly found the current or you correctly found the voltage. So if you found this or that, you get an achieved. Alright, part D. Sometime later, Sam modifies the current in part A by adding one more identical bulb. A current of 2.13 amps is drawn from the battery when the circuit is connected. Explain how the addition of bulb 3 affects the brightness of bulb 1. In your answer, explain if any of the bulbs are now more likely to blow. So, it's always more likely to blow when the voltage is above the recommended voltage. I'm just going to call it VR. So, what we can do is, let's talk about what's actually going on. So, we've added in this bulb here. Now, because it is in a parallel, when we add sort of bulbs in parallel circuits, we're actually going to increase the total resistance. So I'm going to first write that down. Adding bulb 3 increases total resistance of circuit. Okay, that's my first statement. So, since V equals IR and V remains constant, because that's the supply. If R increases, that means the current has to come down. Okay, there's my second statement. Okay, now since the current has gone down, that means there's going to be less, there's going to be less voltage across the rheostat, because V equals IR. If I goes down, that means V also goes down. So we can write less current within the rheostat equals less voltage across rheostat. Okay, because there's less current in the rheostat now, that means the voltage across bulb will increase, because now the rheostat voltage is not taking up as much of the 12 volt supply that's being provided. So voltage across bulbs will increase, which means they will now have over the 9 volts from before. Okay, so since they all have more than the 9 volts before, and if we go back to here, we can see that because bulb 2 and 3 are actually in series with the circuit, that means they're only going to receive half the voltage of what bulb 1 gets, because in series circuits the voltage splits. So in series voltage splits, whether in parallel they all have the same. So that means more voltage is going to be in bulb 1, so that means it's probably going to blow up now, because it's, more than what it had before. So we're going to write down, and we also need to remember to talk about how adding bulb 3 affects the brightness of bulb 1. So let's quickly do that. Since P equals, I'm going to use a new formula, which is not given on the formula sheet, but it's a formula that you can memorize. It's quite helpful. Since P equals V squared, which is the voltage over resistance, is linked to brightness. I've only got a minute before the recording finishes, so I've got to be quick. The increase in voltage is going to increase the power, since the resistance of each bulb is constant. So we can say bulb 1, be specific. Bulb 1 is brighter. And just to finish off the video really quick, I can say bulb 1 more likely to blow, as it's now greater than 9 volts. Didn't explain it that clearly because of the time limit, but it should make sense. So this is an excellence question, a pretty nasty one, because there's lots of things you need to talk about. So full answer would get you an excellence. To get a mirror is correct answer with linked ideas, or just talking about the brightness, so you got up to maybe here. And then achieved is bulb 1 is brighter, and some attempt at linking. So I don't know, maybe somewhere back here. Cheers.